You know, in our digital world, the biggest threats, they're usually the ones you can't even see. They're hiding in your emails, lurking on that coffee shop Wi-Fi, and they can turn a website you trust into a total trap. So today, we're going to pull back the curtain on the world of cybercrime. We'll take a journey from understanding the offense to building a really powerful defense.
All right, so here's our game plan for this explainer. First, we're going to look at how attackers hide in plain sight. How they become ghosts in the machine. Then, we'll get into the art of the trick, the attacks on human trust. After that, we dive into the nasty world of malware, the digital invaders. We'll also cover those overwhelming system attacks. And then, a really cool topic, secrets hidden in pixels. And then, and this is the most important part, we're going to flip the script and talk about building your own digital fortress.
Okay, so before any cybercriminal can even think about launching an attack, what's their number one priority? It's to disappear, to become a ghost in the machine. They have to erase their digital footprints so nobody can trace them. And to pull that off, they use some very specific tools, all designed for one thing: total anonymity. First up, we've got the proxy server. The easiest way to think about this is like a digital middleman or a mail forwarder. When you want to visit a website, your request doesn't go straight there. Nope, it goes to the proxy first, and the proxy sends it on your behalf. So to the website you're visiting, it looks like the proxy is the one asking for the page. Your real IP address, your real location, totally hidden. Now, this gets used for legit stuff all the time, but for an attacker, it's a foundational tool. Now let's look at something similar but way more focused, the anonymizer. If a proxy is like a mail forwarder, an anonymizer is a full-on invisibility cloak. Its entire reason for existing is to make your online activity completely and totally untraceable. It'll often bounce your traffic through a bunch of different servers, encrypting it along the way, which makes it incredibly difficult for anyone to figure out who you are or what you're up to. It's a powerful shield. So what's the real difference between these two? Well, as you can see, it really just boils down to their main purpose. A proxy is usually about control, like a school filtering websites or a company blocking social media. The anonymity is kind of just a side effect. But for an anonymizer, total anonymity is the only goal. That's its whole job. And because of that, the level of privacy you get is just way, way higher. One's for managing access, the other is for disappearing. And here is exactly why this all matters. Attackers use these tools to hide their really are, making it a nightmare for law enforcement to track them down. They can slip past security systems that block certain countries. They use this anonymity to control huge networks of infected computers called botnets without giving away their command center. It's how they can host malicious phishing websites, access the dark web, and trade stolen data, all under this cloak of secrecy. Okay, so now we know how attackers hide. Let's talk about how they strike. And you know what? More often than not, the weakest link in any security system isn't the software, it's not the hardware, it's us. It's human psychology. This next batch of attacks is all about manipulation, deception, and the fine art of the trick. And that brings us to one of the most common threats out there: phishing. I mean, the name says it all, right? Attackers are like fishermen. They cast out some tempting bait, a really convincing-looking email or a text message, and then they just wait. They're hoping some unsuspecting person sees that bait, thinks it's legit, and bites by clicking a link or handing over their personal info. Let's just walk through how this works. It starts with the bait, right? You get this urgent email, looks like it's from your bank, saying there's a big problem with your account. You panic, you click the link. That's step 2. Then, a web page opens that is a perfect pixel-for-pixel clone of your bank's login page. The logo's right, the colors are right, everything looks good. So you do step 4, you type in your username and password. But here's the thing, you didn't just log into your bank. You just handed your login info directly to the attacker. It's stolen. They now have the keys to your account. What's really wild is how phishing adapts. You've got your standard email phishing, which is kind of like casting a giant net just to see what you catch. But then there's spear phishing. That's a targeted attack on one specific person. The email might use your name, your job title, something to make it seem way more legit. Smishing? That's phishing over a text message. Phishing is when they do it over a voice call, maybe pretending to be tech support. And then you have whaling. That's spear phishing for the biggest fish, like CEOs, trying to trick them into wiring huge sums of money. And what's the end goal for so many of these attacks? Identity theft. This is the really devastating outcome. It's where a criminal doesn't just want one of your passwords. They want to become you. They use your name, your credit card details, everything to open new accounts, take out loans, and basically wreck your financial life and reputation.
And the ways they can steal your identity are all over the place. It can be super high-tech, like criminals putting a tiny skimming device on an ATM that secretly copies your card. Or it can happen on a massive scale, like a data breach, where hackers steal info on millions of customers at once. And sometimes it's surprisingly low-tech, like just digging through the trash for old bank statements. But you see the common thread, right? It all comes back to social engineering, tricking and manipulating people to get what they want.
Okay, so beyond just tricking people, attackers also build malicious software or malware. This stuff is designed from the ground up to invade, damage, and control our devices from the inside out. Welcome to the world of digital invaders. Let's start with two classics, the virus and the worm. People throw these terms around all the time, but there's a really important difference. A virus is a parasite. It has to attach itself to a host file. It can only spread if you do something, like open an infected attachment. A worm, on the other hand, is independent. It's a standalone program that can copy itself and just spread across networks automatically, exploiting security holes with zero human help.
Next up, the Trojan horse. And yeah, the name from the Greek myth is absolutely perfect. This malware disguises itself as something you actually want. A free game, a cool app, whatever. You willingly download and install it, basically opening the gates to your digital city. But once it's inside, it unleashes its hidden malicious purpose, which could be anything from stealing your bank info to giving an attacker total remote control of your computer.
Spyware is exactly what it sounds like. It's software that spies on you. It just runs silently in the background, watching everything you do online, collecting your personal info, and sending it back to an attacker. A particularly nasty version of this is a keylogger. It records every single key you press on your keyboard. Think about that. Every password, every private message, every credit card number you type, it's all being sent straight to a criminal.
All right, let's get a little more technical with one that targets websites, SQL injection. So, SQL is a language used to talk to databases. In this attack, a hacker finds a weak spot on a website, like a login box. But instead of typing a username, they type a malicious database command. If the website isn't secure, it can get tricked into running that command, potentially letting the attacker dump the entire database. We're talking usernames, passwords, all of it.
And finally, there's a really fundamental vulnerability called a buffer overflow. Picture a glass of water. That's a memory buffer, built to hold a specific amount of data. A buffer overflow is like trying to pour a whole gallon of water into that tiny glass. It spills everywhere, right? In a computer, that data spill overwrites other parts of the program's memory. Sometimes this just crashes the program, but worse, an attacker can craft that overflow data just right to hijack the program and run their own malicious code. You know, not all attacks are about being sneaky. Some are just about pure, overwhelming force. These are the attacks designed to shut down websites and entire networks just by flooding them with way more traffic than they could ever handle. And that brings us to denial of service attacks. A regular DOS attack is kind of like one person standing in a doorway blocking everyone else. It's annoying for sure, but since all the bad traffic is coming from one place, it's pretty easy to spot and block. But a distributed denial of service, or DDoS attack, that's a whole different beast. It's like a massive coordinated mob of thousands, or even millions, all rushing the doorway at once from every direction. This traffic comes from a botnet of hacked computers all over the world, which makes it nearly impossible to stop. The result? It can knock huge websites completely offline for days. All right, let's switch gears from brute force back to some extreme stealth. We've talked about how attackers hide themselves, but what about hiding the data itself? This next technique is a pretty amazing way to hide secret messages where you'd never, ever think to look. So let me ask you this. You're looking at a totally normal picture, right? A photo of a cat, a landscape, whatever. Could that innocent-looking image file be secretly carrying a hidden text document, or maybe a list of passwords? The answer is absolutely yes.
This is the art of steganography, and it's totally different from something like cryptography. See, cryptography scrambles a message so you can't read it, but you can still see the scrambled message. Steganography hides the fact that a secret message even exists in the first place. It works by making tiny, imperceptible changes to a file. For a picture, this can mean slightly changing the color value of a few thousand pixels. To your eyes, the picture looks exactly the same, but it's now carrying a hidden file inside it. And this, of course, has led to this really sophisticated game of digital cat and mouse. On one side, you have steganography with the goal of perfect, undetectable secrecy, And on the other side, you have steganalysis, which is the science of looking for those tiny statistical clues that give away the hidden data. It's a constant tech arms race between the hiders and the seekers. We have spent a lot of time on the offense, breaking down the attacker's playbook. So now, it's time to pivot. Let's talk defense. Because understanding these threats is really only half the battle. How do you take all this knowledge and actually use it to protect yourself? Well, it's time to build your digital fortress.
First, let's cover the absolute fundamentals. These are the things you just have to do. Having trusted antivirus and anti-malware software, that's your frontline soldier. Keeping your system and all your apps updated is critical. Why? Because those updates often fix the very security holes that attackers are trying to use against you. Being skeptical of downloads and email links, that's your gut instinct. And using a firewall is like having a vigilant gatekeeper for your network, watching everything that comes in and goes out. Now, to protect your actual identity, good password habits are everything. This means using long, complex, and, this is key, unique passwords for every single important account. A password manager makes this so much easier. Next, turn on two-factor authentication, or 2FA, everywhere you possibly can. That little extra code sent to your phone might seem like a hassle, but it's a massive roadblock for an attacker. It means even if they steal your password, they still can't get in. And just stay vigilant. Keep an eye on your bank statements for anything that looks weird. And look, it's not a one-sided fight. On a global scale, cybersecurity pros are always working to tear down the infrastructure these attackers use. They disrupt massive botnets by sinkholing them. Basically, they take over the criminals' command servers. They work with law enforcement on takedown operations to physically shut down criminal servers. It is an active, ongoing battle every single day. So let's end with this one thought. In today's world, that line between our digital lives and our real lives, it's pretty much gone. They're the same thing. Your data is your property, your identity is your own, and your security is your responsibility. The most important thing is that understanding the threat, knowing the playbook we just walked through, is the most powerful first step you can take. The next step? Well, that's up to you.